So this is question 1, and you have a diagram representing 3 villages, A, B, and C, and together they form this triangular shape with the roads between. So for the first part of the question, you're asked to find the length of road A to B. So I'm just going to draw that onto my diagram. And with the information that I've already got, I have 2 sides and an angle. So if I have 2 sides and I want a third side, and I have 1 angle, then that's leading me into using the cosine rule, which is C squared, is equal to A squared plus B squared minus 2BC cos C. So with the labels on the triangle, I can always change them if they're not what I need for this question. But they actually work very well. So this would be angle C, side C, side A, side B, and then the angles are already labelled. So I'm just going to use the cosine rule and the information and then plug that in. So C squared is equal to 8 squared plus 10 squared minus 2 times 8 times 10 cosine of 150 degrees. So I can now just go to my GDC, so clear whatever is on there, and we can type that in. Now it's up to you how you solve that one. I'm going to use a numeric solver. So the first one is x squared. This is the left-hand side of my equation, and I'm calling it x. And then the second side is 8 squared plus 10 squared minus 2 times 8 times 10 times, and it's cosine of 150, and always double check that you're in degrees. Okay, and then I'm going to press solve, and it's 17.394. So to 3 significant figures, that would be 17.4 kilometers. And don't forget your units. It says find the length of the road, so it's asking for it in real life, so we need to have our units there as well. And then part B says find the size of angle CAB. So C to A to B. C to A to B is this angle here. So that's what I'm trying to find. That's what this means. You're drawing from C to A to B. So for this one, if I'm now trying to find this angle, I think the easiest way of doing that is going to be to use the sine rule. I now have this measurement and this measurement, and I have this one, and this is what I'm trying to find. And these are opposite one another, and these are also opposite one another. Okay, so I think that's probably going to be the easiest one to use here. So I'm going to use the sine rule, and sine of angle A, which is what I'm trying to find, is opposite length A, and I know that sine of angle 150 is opposite. Now I'm going to write it slightly more exact than what I had in the original question, just so that I know that I've kept all my degrees of accuracy. And again, I could just type that into my numeric solver, and that would give me 13.3 degrees to 3 significant figures. Now it says that village D is halfway between A and B. Okay, so on my graph that looks like, or my diagram, it looks about here. And a new road perpendicular to AB passing through D is built, and they've drawn that for us just here. So we now need to write down the distance from A to D. So the distance from A to D is this bit here. Now we do know, and I'm going to label it on my diagram, that the whole distance across is 17.4. So I just want to remember that that whole distance is 17.4. And you're told that it's halfway across, so it's halfway between A and B. And so it's just half of 17.4, and so the distance between A and D, this one here, is half of it, so it's just 8.70 kilometers to 3 significant figures. And then part D, we have to show that the distance from D to T, so D to T, which is this distance here, is 2.06. So this is a right angle triangle, and therefore I can just use SOHCAHTOA. So I have this measurement here. Let me highlight them. I have this side here. I also have this angle here. And therefore, the easiest way of doing this one, if I have this angle, this is the opposite, the hypotenuse, and the adjacent. So I'm just relabeling it. I'm looking for the opposite, and I already have the adjacent. And therefore, when I think about SOHCAHTOA, I'm wanting to use the tan option with the opposite and the adjacent. So tan of the angle, which is 13.3, I found that in part B, is equal to the length dt, which is what I'm trying to find, that's the opposite, over the adjacent, which I just said was 8.7. And if you had done one of the previous answers wrong, so B or C, you would still get method marks for using this same method. And again, I can type that into numeric solver, and I find that the length of dt is 2.06 kilometers, which is good because they tell us to show that that's true. And then for the next part, it says that a bus starts and ends its journey at A. It goes from A to D, D to T, and T to A. And we need to find out how far the bus goes in total. So that means that we're trying to find the full distance for the journey. So we need to now find the length of T to A. That's the only one we're missing from that journey because it's going from A to D, and then T to A, D to T, which I've got, and then T to A is what I'm missing. But all the other measurements I now have. So again, I could just use my SOHCAHTOA to find the missing side that I'm looking for. Again, this is my angle, and so I'm still having the labels exactly how I've already set them up. But this time I want to find the hypotenuse. And again, I already have the adjacent. So this time I'm going to use cos. So cos of 13.3, which is the angle, is equal to the adjacent, which is 8.70, over the hypotenuse, which is what I'm trying to find, which is distance TA. And if you type that into your numeric solver, you'll find that distance TA is 8.94 kilometers. So we can label that on our diagram if we want, 8.94, and we already know that this is 2.06. So now I can find the total length of the bus, and the bus is going to travel 8.70, and then it's going to add on the next part of the journey, which is 2.06, and then it's going to add on the next part of the journey, which is 8.94. So in total, the bus travels 19.7 kilometers. And then for F, it says that we need to estimate how long the bus takes to complete that journey, and it tells us that it's traveling at 70 kilometers an hour, and it stops for 5 minutes at each stop. We know that speed is equal to distance over time, and that's given to you in your formula book as well. We need to make sure that the units are all the same, so we're working in kilometers per hour, so we need to put everything in hours or kilometers. So speed is 70. We know that it travels 19.7 kilometers, and so this will tell us the time in hours. And again, I could put that into numeric solver and find that it's 0.28 hours. But it asks me to give it to the nearest minute. Okay, so we now need to find how many hours is 0.28. So to do that, we're saying that 0.28 of 60 minutes, which is 1 hour, is equal to what? So we're going to times it by 60, and that gives me approximately 16.89 minutes. But we need to remember that the bus stops for 5 minutes at each stop. So I need to add on 10 minutes for each of those stops, one at D and one at T. So that's going to give me 26.89 minutes, which to the nearest minute is going to be a 27-minute journey. And that's how long the bus is going to take to complete its journey.